hour. I think you can. I hope you had a very nice TAF day, and I think you can relax, lay back with a cup of tea. And I will tell you a little bit about our journey at the AI-based services and innovation sector within DGT towards contributing to better multilingual AI in Europe, and also the role of supercomputers and language professionals in this project. My name is Ilya Rausch, and my colleagues Bhavani Bhaskar and Christian Brashoviano are also present in this call, and they are available for you in the chat. So if you have any questions during this presentation, please feel encouraged to ask those questions in the chat until the Q&A, of course, where we can have a more interactive conversation. Okay, let me try to make sure that the slides are working again. And let me try to click. Right. All right, let's begin with the project background, where I will describe a little bit what exactly, which AI are we talking about, and how translators could or potentially might contribute to this, and which work is already actually quite useful there, and which challenges we're facing. So let's begin a little bit with the concept of AI, artificial intelligence. Which one do we mean here? Nowadays, the state-of-the-art cutting-edge applications, many of them use the large language models in their core as their engine. And this includes not only some proprietary private sector applications, but even also within the DGT, our AI-based services like e-briefing and e-reply use a large language model under the hood. And it is important to note that those large language models are models. They are language models, so they are quite well. They're doing quite well in representing or reproducing to some extent human interactions or human way of communicating, especially the text-based large language models. And they are large because they really have an unprecedented size compared to previous AI models. And this size comes with really a stunning performance, but at the same time also with a lot of challenges. And I already stressed that those are models. Why do I stress that? What do I mean by this? There is a famous quote by George Box, who wrote in the 70s, "All models are wrong, but some are useful." George Box was a statistician and a physicist, and even in physics, it was important to stress that models have their limitations. For example, gravity, when I throw a ball, I can predict more or less where it will land, but this does not hold in all circumstances, in all possible circumstances. So sometimes these models can be really wrong, but often they are useful. However, nowadays, I believe it's important to turn this a little bit around, because there is a lot of news, a lot of hype out there about how great AI models are, and our general and artificial general intelligence is around the corner, etc. So just for today, I would like to also mention that not only the words matter, but also their order. And so I would like to say that some models are useful, but remember, all models are wrong. And I'm saying this because the large language models, which are not just hype, they are useful in many ways. And we've seen their really astronomical rise in the couple of years. They also have limitations. And those limitations and potential risks of that generative AI are quite well outlined by a report by the Council. But some of those limitations include the lack of transparency about the training data. For many of those models, we cannot really say what data exactly was used to train those models. They also include biases and influences, certain worldviews that might have creeped in from the developers of those models or the evaluators or the data set developers as well. And this is also very important for us, especially at DGT. Those LLMs have a poor language coverage, especially when it comes to EU languages. And this is where we see really some opportunity to contribute to the European ecosystem of LLMs, ideally within the Digital Euro program, with the data, with the multilingual data that we have available through the EuroHPC database. I will tell you a bit more about that in a minute. It's a interinstitutional database where all of the EU languages are represented. And we hope that with that data, we can create a more multilingual AI. So a little bit about the data and about what DGT produced. Those in 2023, so about a year ago, those were more than 2.5 million pages. And as you see, the distribution of the languages is relatively homogeneous. For every language, there is a six-figure number of pages really that were translated. And crucially, this applies also to languages that are so-called low resource languages, like Gaelic, Slovenian, Lithuanian, etc. So we have a lot of high quality texts in all of the EU languages, all of the EU official languages. And in terms of types of texts or categories of those texts that were translated, as you see, the majority is from the EU lawmaking, but there are also texts from the communication efforts, from other official documents, correspondences, etc. 60% of which were translated in-house and 40% outsourced. So we really have with this a great treasure trove of data, and it is saved and can be accessed through the EuroHPC database, which was initiated in the 90s. So it's quite a long-lasting effort. And nowadays it includes actually already almost over 100 billion so-called tokens. A token is a part of a word. So for example, the word database can be broken down into two tokens, data and base. And this is a respectable amount of words. This is a respectable size of data. It is not as large as all the web, which is in trillions, dozens of trillions of tokens, but it is nonetheless, especially for those low resource languages, a quite valuable and important source of data. So with this, this is great that we have that data, but what are the challenges of building this kind of AI? Well, the challenges are really manifold. So on the one hand, you want to train a really large language model because typically the size of the model correlates with its performance. Often one can see that the bigger the model, the more performant it is. And here I'm symbolizing it a little bit in terms of a skyscraper. At the same time, you want to train on as much data as possible. You want to supply as many examples as possible to the model so that it learns as long as possible. So really the data size multiplies a little bit this size problem. And at the same time, we also have a very limited amount of time for which we can train. So the computational resources are limited. We need to be vigilant. We need to be as efficient as possible, use those resources as effectively as possible. However, those computational resources are also limited in their capacity. So for example, one very crucial part of it is the GPU memory. GPUs are graphical processing units. Those are just computer parts, computer chips that are especially effective for working with AI, for training AI. However, their capacity is not as large as one could wish it to be. Nonetheless, I should mention there is really a tremendous amount of engineering that was involved into building the GPUs that we see today. So the progress is really astonishing. Still, they are limited. And because they are limited, we need to use several of them, not just one. But those units, those GPU units, have to communicate with each other. So they have to send data back and forth. And to send the data, which goes through wires, there is a limited bandwidth. So the time that the data goes from one GPU onto another um, is finite. So you need to wait for a certain amount of time. So all of this slows down again the training. So at the same time, you want as large data, as large models as possible, but you're limited in terms of how quickly you can train that model, and you're limited by the computational resources that are available. There are several ways to overcome those challenges. I won't go into too much detail, but for those who are within the audience who are interested in AI engineering, so one efficient way is to use parallelization. So here I'm using a metaphor from kind of a more accessible metaphor where we want to move certain offices or office supplies, let's say from several skyscrapers onto another place. We want to try to pack that into as many vehicles as possible. But if we do this inefficiently, those vehicles um, will slow down each other. So what you would want to do is you want to spread it over all the lanes more or less equally so that you can transport the data or the office supplies at the same time efficiently without interferences. Other techniques include gradient accumulation and flash attention, which are techniques that take into account the hardware limitation and try to increase the efficiency of the computations given those limitations. And the reason why this is still, despite all those challenges, it is still possible, and we can also, to some extent, do this, and we're working on this, is because we have this great enabler, EuroHPC joint undertaking, which owns several supercomputers in Europe. And I mentioned to you before, the hardware is a very important component, very important feature. And supercomputers provide a really powerful hardware. Without those supercomputers, training an LLM would not be possible within a human lifetime, or maybe not even possible without several human generations. But with supercomputing power, you can train or build AI within a reasonable time frame. And we were also, in our team for our project, we were lucky to get access to some of those supercomputers. And in fact, this point is so important that one could divide our project into several phases based on the access, those different access types that we got uh, through EuroHPC joint undertaking. So let me first outline phase one of that project, which ran from November 23rd to May 24th, um, year 2023 to 2024. And there we used a model called Llama, hence the picture here. A little bit about this right now in the coming slides. So when you look at the ecosystem of LLMs overall, you could see this picture kind of depicts quite well the distribution of the sizes. And you probably are familiar with GPT-4. You probably heard also of Gemini or Claude. Well, the Llama model that we used a year ago is situated somewhere here. By today's standards, it's considered extra small. A year ago, it was still in the medium range. So the Llama 2 contains 13 billion parameters. It is already large enough to be challenging and to need a supercomputer. In fact, when Meta trained that model on their cluster, they needed around 370,000 GPU hours. 370,000 GPU hours. And you can think of it this way: if you have 370 GPUs, each of them train for 1,000 hours because you can parallelize this training. However, Meta trained that model from scratch, from zero. We were able to access only 12,000 GPU hours. So for us, it was not feasible to train a model from scratch. We did not have the access to such a large resource and such a large capacity. Instead, we opted for continued pre-training. This means we took the Llama model, which was pre-trained by Meta, and we continued the training of this model on the EuroHPC data. And we had a pretty good case for doing this, because in the distribution of the languages of the data that Meta used, only about 20 million tokens existed for Slovenian and Croatian. Whereas in the EuroHPC database, we have several billions of tokens for those languages. And the amount of tokens is also relatively evenly distributed over other languages. So this also means that for other low resource languages, Lithuanian, etc., as mentioned, we also have several billions of tokens. So this means that actually in our set, we have more data for those low resource languages than Meta had a year ago, at least. Right now, at the moment, the latest models that they trained, it's hard to say which data exactly they used. So it's difficult to say how many tokens they used there. But it's very, let's say, we can definitely say with quite a high certainty that the quality of the texts and the data available through the EuroHPC database are really, really high, and probably a lot higher than the majority of the data that is normally used for training those LLMs. And we had access to the Meluxina supercomputer, which is found in Luxembourg. And we used about 32 A100 GPUs. So GPUs, as mentioned before, graphical processing unit, computational units that are especially good for machine learning and AI workloads. And A100 just means they were state of the art a year ago. Today, they are rather the grandparent generation to the today's state of the art. So as you see, the progress of developing this hardware is very, very quick. And as mentioned before, we took the base model, the Llama 213B, as is, and we basically continued where Meta left off, and we trained it first on the Slovenian tokens. This is the so-called SL model. And then we continued the pre-training additionally on the Croatian tokens. So these two models, SL model and the HRSL model, are quite important. We will delve a bit more into them in the coming slides. Namely, when we talk about the evaluation. Evaluation is a crucial part of every AI training process, where you need to be vigilant, you need to measure the performance of the model well, and also from different perspectives. And we also use different angles to try to understand how the machine learning model was trained on those tokens. So first, we measured, of course, in very standard ways. This is an abstract metric, so-called cross-entropy loss. You want to reduce the loss as much as possible. The lower the loss, the better the performance of the model. But I'm showing this here to you just qualitatively to show the trend. So the trend, the loss indeed was decreasing over the iterations, over the number of training steps. And in fact, it was decreasing continuously, and it is to some extent qualitatively similar to what OpenAI also observed when they trained their GPT-3 model, which was really the origin of ChatGPT. So at least qualitatively, trend-wise, this is great. This could be considered quite a success to train a model in that way. Additionally, we measured using common benchmarks. So those benchmarks are often question answering texts, so multiple choice questions. The model gets those questions and has several options to reply, and then you measure how many times the model picked the correct option. And both benchmarks show qualitatively similar results. On the one hand, for the target language on which the model was trained, so you read it in the following way: the English part was so the question was asked in English, and then the answer was in Slovenian. Similarly, here the question was in Slovenian and the answer also in Slovenian. So when the answer was in Slovenian, then the performance improved compared to compared to Meta's Llama model, and we see a similar trend for creation. However, we also observed that on the English language, question in English, answer in English, the performance decreased. And this is a hint that shows potential for so-called catastrophic forgetting. The model starts to forget some of the skills, let's say, that it had, some of the capabilities. Similarly, we also measured it in terms of machine translation. And in this graph, you can focus on the squares. So this is a score for the machine translation score. I will not go too much into detail here. Just know the higher, the better. So when we measured Meta's models of different sizes, the score increased. And for when we trained the model on Slovenian tokens, it really performed the best when it came to translating text from English to Slovenian. However, when we subsequently trained the same model additionally on creation, its performance on Slovenian decreased. So here again, we see catastrophic forgetting. It improved in creation, but it decreased in Slovenian. Finally, we also used human evaluation, and we're grateful for all the volunteers who helped us with this. About 56 volunteers from different DGs helped us measure the performance of the model. And the task was the following: the model got a certain input, some incomplete sentence, and then there were actually two models. The evaluators only saw the output of model 1 and model 2, but the evaluators didn't know what is model 1 and what is model 2. So, and then they evaluated their performance in terms of fluency in reference and, relevance. So here is a less abstract example. This was an input in Slovenian and also the replies in that language. So when we translate it to English, it's roughly something like an input in the beginning of a sentence talking about a virus, and Meta's model responded with some CV description, whereas the model that was continued pre-trained by us actually included text that was related to some extent to viruses. So in this case, the model indeed performed better than the base model. And overall, one can say that still we saw certain catastrophic forgetting, because here, for example, the creation model, the HRSL model, which was trained before as well on the SL model, actually is inferior to its predecessor. So we see some catastrophic forgetting, but we, on the other hand, also see that there was a strong preference compared to the original Meta's model in some cases. All right, and this brings me to phase 2. With all the experiences that we gained in the previous phase, we would like to apply those lessons learned now to a bigger model and to a different one. This time we want to use a European model, a Mixtral model, which is a mixture of experts. So this image somehow supposed to be representing experts. This project, it's another development access, and we actually also obtained even bigger access on the supercomputer AI axis, which will also start a little bit later. So the Mixtral model is situated somewhere here, so we can call it large, even by today's standard. But it is quite challenging to train such a model at this scale. Additionally, we intend to use the entire EuroHPC database with all the 24 official EU languages. But luckily, we have a higher amount of GPU hours available to us this time. And we also will train it on a supercomputer that is more powerful than Meluxina, than the previous one. We will also try to train on more than 32 GPUs. And I was lucky to get the chance to visit that supercomputer in person. So this is a picture I took last week. And it really looks like shelves in a library, but where books are stacked not in this way, but in this way. And each cell of those shelves represents a computer that is at least 5 to 8 times more powerful than the laptop that you have on your desk, on the personal computer. So this is a very powerful machine. But note that we don't need the entire power of this machine. We will only use maybe 8 or 10 or so of these cells. So this brings me to kind of the next stages. What are exactly the next steps that we have planned in this phase? What might be other future projects or intentions? So, yeah, thanks. Last two slides. So on the one hand, we want to mitigate that catastrophic forgetting that we observed previously. And we also need to optimize the training speed in order to be able to scale to a larger model. Then we will, of course, do the training and the evaluation, different stages of evaluations that I mentioned before. We also will try to do the alignment process. So here it is about making a model not only performant in terms of usefulness, in terms of being helpful, but also reducing the harm and assuring that the AI model is really understanding the task and is doing what you actually intended to do. And finally, we also hope to potentially open source the results following Commission's open sourcing policies, or maybe offer the model in terms of inference. So in the future, we hope to end up with a more multilingual LLM with all 24 EU languages included and being strongly represented in that LLM. We hope to offer it to SMEs, academia, and public institutions through the Digital Europe program, potentially integrated into the AI-based services that we already have right now. And really, we are also intending or really trying to keep Europe future-proof. We try to keep the skills and the know-how also within the institution with this project. We hope also to help make better decisions and really understand this field. Thank you, everyone, for this is our team. Thank you for your attention. Thanks also for the contributors, to the advisors and observers. And I'm ready to take your questions now. Any questions?
Leo, there are a couple of questions in the chat. Maybe I can assist you a little bit and pick them. So one of the questions is, what are the use cases that we had in mind for the Slovenian and Croatian LLMs, are they general purpose, or we had specific tasks in mind?
Okay. I can respond if you want, or I can start and you can complete my response. So I think first of all, one of the reasons we went for continued pre-training, or to be very fair, actually that decision was made before I even joined the team. So I'm just trying to answer it in a correct way, but then feel free to correct me, please. So one of the reasons why the decision was made to go with continued pre-training is to keep the general purpose of the LLM, to keep it not necessarily specific to a certain task, but be able to be flexible also in terms of tasks. And I think also always there, as I mentioned before, there was an intention to potentially use it also as an engine behind our AI-based services. Anything you would like to add, Christian or Bhavani?
Maybe we can also say that we picked two languages because, as Ilya explained, there was a limited amount of GPU hours, so it was not possible to do more than two. So that was the smaller scale type of project. And Slovenian and Croatian were picked not specifically, but rather because they are low resource languages. So we wanted
Yes.
to see in particular for those languages. I don't know if Bhavani wants to add anything, but if not, we can.
No, Ilya covered it. We basically wanted a general purpose model because that's easier to fine tune than picking a fine tuned model and then going back.
So in the end, the focus, we had a lot of discussion about what to do, whether to fine tune or do continued pre-training, or even in the future, maybe do full training from scratch. And there was a lot of discussion also about this aspect of some things for specific tasks or for specific domains. It's a field with a lot of uncertainty about the future, so we had to make certain decisions, and in the end, in this particular project, the focus was to see whether the high quality data, multilingual text data that we have in DGT and from the other institutions as well, whether it can be useful in improving the multilingual capabilities of the model. So the model stays general purpose, but the investigation and the hope is that our high quality data covering all the EU official languages can have an impact on the capabilities of such a general purpose model also in the languages that are not so well represented in the training data originally.
Yes.
Maybe we can pick the next one. For training the models, is AI used both for training and evaluation? Where and how does the human interfere or intervene? Do you also train the models to recognize the source language, in the presented case, Slovenian and Croatian at the same time? Ilya, maybe you can.
Yes. So in our case, we did not use AI to evaluate the model, as far as I know. Instead, we used certain benchmarks that do not necessary. You don't need machine learning or an additional model to evaluate as a sort of a parent or a teacher the model that we trained. The role of the humans in this case was quite crucial because whatever abstract metric you use, you always want to make sure that it is useful to the human. And the human perspective in this case was covered through those evaluations by the volunteers. Was there any other part of that question? Did I cover that?
The language detection, I think.
Yes, thank you. Indeed, for the language detection, as far as I know, there was also nothing specific that the model was asked to detect the language itself during the evaluation, maybe during the machine translation, but I don't think so.
Not really, no. Basically, it's implicitly learned and not specifically.
Maybe we can add a little bit, Ilya and Bhavani, that yeah, in LLMs there are a lot of automated benchmarks and metrics where you have certain data sets and where you can evaluate the performance of your model. But then there are a lot of use cases, as we discover, where it's not that easy. I mean, when you have a piece of text and you have a question and a certain answer, maybe a number or maybe a name that has to be recognized in the text, it's more easy to have a data set to evaluate the performance of the model. If it can answer the question. But in some of our services, like e-briefing or e-reply that Ilya mentioned in the beginning, it's like you write an article and you create an application that uses a large language model that generates a more extensive piece of text. That is a lot more difficult to put in a straight jacket in a data set and to say
Yes.
this is a good answer and this is a bad answer. It's not that it's not objective anymore, but the quality of a piece of text becomes a lot more subjective compared to a simple question answering system. So I think it's one of the challenges of evaluation when you go into more complex use cases and more complex types of output.
Indeed, and just to complement that, it is also quite important to have those data sets or those evaluation metrics in multiple languages. This is, I think, also where the humans and the language professionals really can become very crucial, because there is still a relative lack of high quality evaluation data sets for low
Constantly the
resource
flashback
EU
because
languages.
everything is frozen. You can't get around the 40
Sorry,
days.
may we
Baby
ask
and golden
everybody if
baby 40
you
days.
don't speak to keep your microphone on mute because there's background noise. Thank you. I'll pick another question, Ilya. If we have any partnerships with external organizations, for example, universities, private companies, to support LLM research and development. I mean, you've also been with us for a while now, so you know that we have had some contacts. We have had exchanges, like for example, in the very beginning, we knew about the Nation Library in Sweden, who I think was the very first public sector entity who had a EuroHPC project using a supercomputer in the EuroHPC network. Maybe we were second, but their experience was very, very useful, and it was very useful to have an exchange. And I think, Ilya, you and Bhavani also have plans for more exchanges with other entities like that, right?
Yeah, absolutely. 2 weeks ago, I was lucky to participate in the EuroHPC User Day, where I got the chance to really meet a lot of users of those supercomputers, and there were several ones who actually used that also to train large language models. Some startups actually who also have as a goal to train EU LLMs that are multilingual, that include all 24 EU languages. They are taking a little bit different approach. They are trying to pre-train the model from scratch, as opposed to continued pre-training is what we are doing. But indeed, and in addition to this, of course, there are also universities, research teams. We had an interaction, for example, also with a group from Slovenia, who are also trying to train a Slovenian Slovenian LLM. So we are I would say, in constant exchange also, and we're trying to keep a good overview of the field of the European LLMs.
In particular, our colleagues at DG Connect are the ones who manage funding programs for projects that include projects for the development of LLMs and data sets specifically for LLM training and so on. And of course, we stay in touch with them and we follow what happens those projects as well. And I think it's a continuation of the question also from Alexandra, whether there is a roadmap for developing models. I assume it's a question about whether we have a roadmap for our own models, what we think we may be doing in the future. Ilya, would you speculate a little bit?
Oh, yes. I guess this slide, one second, this slide covers it a little bit. So I think on our roadmap, really the first task is to try to find out how can we continue the pre-training of a model such that it learns the subtle differences between some of the languages. We've seen with Slovenian and Croatian how challenging it can be without forgetting, without losing its capabilities in other languages. So this is a really difficult task. There is not so much literature on that yet because it really is cutting edge work. So I think this will be one of the first steps for us. At the same time, on our roadmap is to become better at using supercomputers efficiently. Those are important and expensive resources, and we want to make sure that we use them to their best extent. And once we are, let's say, are comfortable at least in both with both challenges, we want to do the training of the large Mixtral model of Mixtral 8 times 22B. And this training is it will require quite some work, but also it will take some time. It could take several months. Once we have this, we need to, and also actually in the process of training at different stages, we need to evaluate the performance of AI. We need to monitor how it is going. And we also need to prepare the data sets for alignment or fine tuning to really make sure that the AI is doing exactly what we want and is solving the tasks that it is given.
So maybe I can also complement to say that as the European Commission and also as the Digital Europe program, the focus is in particular on the European ecosystem and to contribute to the European AI ecosystem. So we are keeping an eye on and following what European startups and European projects, whether funded by the EU or other projects, are going to release as open source models in the coming months, because we cannot say in the coming years. That's a very long time in AI terms. So very much the focus will be on European models and not necessarily to create competition to those models, but rather to take them and to add something to them to improve their capabilities in one way or another. And another thing that we expect to happen is to see an acceleration as well, because as Ilya explained, we had a certain type of access with a limited number of hours, and even this one, the bigger one, still has a limited number of hours when we think in terms of AI projects, especially for larger models. But as some of you may have seen in the speeches and the political guidelines of our president, one of the priorities is to set up new AI factories that are going to be specialized supercomputers that are going to provide a lot more scale and speed to be able to, as the name says, to be able to produce large language models in Europe a lot faster and a lot larger as well. And maybe we can take one last question, because I think we are at the end of the session. Are there training program or support system for translators to learn about AI tools and leverage them in their work? Ilya, you can.
Sorry, could you repeat? So are there any programs for
Are there
translators?
training programs or support system for translators to learn about AI tools and leverage them in their work? I mean, I suppose we can speak of what happens inside the Commission itself, because inside the Commission over the last couple of years, there has been a lot of effort to adopt and to integrate AI technology, not specifically just for translators, but more generally. And in DGT specifically for translators, I mean, there has been a policy of making machine translation part of translators' everyday work before, and now, of course, there will be more focus on new possibilities with assistants and other types of new AI application. Outside, as many of you may know, DGT is also supporting the network of European Masters in Translation, and I am not myself familiar with that area specifically, but I assume that those programs are more and more integrating courses and modules about the use of the new type of AI technology in translation as well. I don't know, Ilya or Bhavani, do you have other
Yeah.
specific ideas that come to mind?
Within the EuroHPC network, please join the network. We have regularly different webinars and events that also help inform about AI and help inform what you could do with AI or what AI is. So we record those sessions and they are available through EU Learn as well. So even if you're curious a little bit more about the fundamentals of large language models, for example, we have a separate webinar, recording of a webinar there on the EU Learn. So check it out.
That is an invitation to those in the audience who are in the EU institutions. Those who are from outside, unfortunately, these are not available outside, but
Indeed.
there are sessions organized, for example, by our colleagues in DG Connect as part of the Connect University sessions that are also available in YouTube, where some sessions cover AI specifically. Yeah, I see one last request from Alexandra.
Yeah, sorry, we're
Yeah.
gonna have to wrap it up, but you can for sure finish, have your last word.
Yeah. So Alexandra, you can send messages to either to me or to Ilya or to Bhavani, and we can get in touch and we can have some other exchanges. And I leave it to Ilya to say the final words.
Well, thank you everybody for joining. I hope you had a good overview now of what we're trying to do within the DGT, also to keep up with the current AI trend and also with training large language models. I would say the future holds a lot of acceleration, as Christian said. Remember, some models are useful, all models are wrong, but also the other way around. All models are wrong, but many models are useful, and I hope that in the future they will really help us to also increase the productivity of our work or maybe make it even more interesting. Thank you.